Hello students, in this video I am going to talk to you about the number of stereoisomers of dichloropentane. This is in response to one of the questions raised by a student, JEE-MAINS student of mine, who is going to give the JEE this year, and he asked me this question, so I am putting it out as a video for the benefit of all. So when we look at this molecule dichloropentane, so this is a pentane molecule with two of the hydrogens substituted by chlorine atoms. Now the chlorine atoms can do the substitution on the same carbon or on different carbons. Okay, so the possible isomers we get this way. I'm only talking about the position and not the stereoisomer. So the position isomers are as follows: 1,1, where both the chlorine atoms are on the carbon 1, then 2,2, 3,3, 1,2, 1,3, 1,4, 1,5, 2,3 and 2,4. Okay, how do we get this? See, look, 1,1, 2,2 and 3,3 are legit isomers, but 4,4 and 5,5, they are not legit, because 4,4 is the same as 2,2 and 5,5 is same as 1,1. Similarly, the legit isomers here are 1,2, 1,3, 1,4 and 1,5. Okay, and the chlorine atoms are on carbon 1, carbon 2, carbon 1, carbon 3, like that. Okay, and also 2,3 and 2,4, but here we don't consider 2,5 because it is the same as 1,4, 3,4 is same as 2,3, 3,5 is same as 1,3 and 4,5 is same as 1,2. So these molecules are discarded because they are the same as the previous isomers by virtue of molecular symmetry. Okay, so the complete distinct possible positional isomers are 9, 1,1, 2,2, 3,3, 1,2, 1,3, 1,4, 1,5, 2,3 and 2,4. Okay, all right. Now we are going to look at stereoisomers. Okay, since the molecule under consideration have no double bonds, so there is no possibility of geometric isomers here. So we have to look only for the presence of chiral carbons. Okay, we can see that the 1, 1, 2, 2 and 3, 3 have no chiral carbons. The 1, 2 has a single chiral carbon on C2, 1, 3 has a chiral carbon on C3, the 1, 4 has a chiral carbon on C4, the 1, 5 once again has no chiral carbon, the 2, 3 has two chiral carbons on C2 and C3, and the 2, 4 has two chiral carbons on C2 and C4. Okay, so we can see in these structures I have marked the chiral carbons in orange. Okay, you can see that the 1, 1, 2, 2, 3, 3 and the 1, 5 don't have any chiral carbons. Okay, whereas the 1, 2 has got a single chiral carbon, so also 1, 3, 1, 4 and the 2, 3 and 2, 4 have got two chiral carbons each. Okay, now we will look at the number of stereomers for each of the cases. See, the 1, 1, 2, 2, 3, 3 and the 1, 5, they can exist only as a single isomer. So in this case the total is 4. Okay, 1 each. Okay, 1 plus 1 plus 1 plus 1 is 4. Okay, and now for those molecules having a single chiral carbon, there will be now two isomers, right? So the 1, 2, 1, 3, 1, 4, they have got a single chiral carbon. 1, 2 has got chiral carbon on C2, 1, 3 has got it on C3, and the 1, 4 has got it on C4. So totally there are two isomers each. So 2 plus 2 plus 2 will be 6 here. Okay, now those two molecules that have got two chiral carbons, okay, so the number of possible stereomers will be 4, right? Because the formula is 2 raised to n, where n is the number of chiral carbons. So 2 raised to 2 is equal to 4. Okay, so now you can see that the 2, 3 has got two chiral carbons on C2 and C3. Okay, so it has got a total of 4 isomers: RR, SS, RS and SR. So now this should be the same case for 2, 4 also. Okay, it has also got two chiral carbons on C2 and C4, so there should be 4 here too, but there is only 3 here. And why would that be? So let us look at the special case of 2,4 dichloroisomer. We can see that there are 4 isomers here as expected: RR, SS, SR and RS, but then the SR and RS merge into one molecule. Why is that? Because it is a meso compound. So what do you mean by meso compound? It has chiral carbons, but it is achiral because there's a plane of symmetry. And in this case, there's a plane of symmetry. You can see the orange line passing through C3, okay, of the molecule, bisecting the molecule into two identical halves, so that this molecule, in spite of having two chiral carbons on C2 and C4, it's achiral. Okay, so total number of isomers for the 2,4 isomer is 3. Okay, so which means, so let us now compute the total stereomers for dichloropentane. Molecules having just one isomer, there are 4 of them. Molecules having 2 isomers, okay, there are 6 of them. And the molecules having more than 2 isomers, there are 7 of them. So the total stereoisomer count for dichloropentane is 17. Thank you.